Hello maths friends, this lesson we're learning about parallel lines and particularly some things with basically what they are. Remember, we're looking at the topic of coordinate geometry. Okay, so that's our context for this, and we've sort of number planes, points, lines, gradients, midpoints, all that sort of stuff. What are parallel lines anyway? Like, what are they? What makes two lines parallel? Okay, I want you to have a think about that yourself, and we'll go through the answer to that in class. Secondly, what is special about the slope of parallel lines, the slope or gradient of parallel lines, and how does that affect its gradient? Let's have a think for a moment. Say we have two parallel lines, okay, AB, that has an angle θ1 and gradient m1, okay. Then say we have another line, CD, with angle θ2 over here and gradient m2. Because the angles of inclination are equal here, then basically the lines are parallel. Okay, why are they equal? Well, they're actually equal because if you look at these two lines, if you look at these two angles, you'll notice that they make an F shape. So they're actually corresponding angles. And remember, from geometry, we can use corresponding angles to the converse of corresponding angles on parallel lines are equal. That is, if there are corresponding angles existing, then the lines must be parallel, and that's what they've said here. So therefore, two angles are equal. θ1 equals θ2. Also, m equals tan theta. Tan θ1 is tan θ2, which then tells us that therefore the gradients are equal. So what is special about the slope of parallel lines? If the lines are parallel, their gradients are equal. Okay, that's really important that you write that down. Let's have a look at some examples. These are the sorts of questions you'll get. But be careful. This question says to prove. You know, any proof question is more than a 2-minute question. Okay, well, if you're really good, you could probably pull it off in 2 minutes. Prove that the straight lines 5x minus 2y minus 1 equals 0 and 5x minus 2y plus 7 equals 0 are parallel. Well, how are we going to show that two lines are parallel? What we're going to do is to prove that their gradients are equal. Okay, so what I'm going to do is I'm going to call this line 1 and I'm going to call this line 2. Alright, so the gradient of line 1, to get that, I'm going to need to rearrange it. I'm going to get it into gradient to intercept form. So basically, to do that, I need y equals mx plus b. Okay, so 2y, so I'm pushing the y over here, is 5x minus 1. Divide everything by 2, so y is 5 over 2x minus a half. So that gives me my gradient there, 5 over 2. So I'm going to go, therefore, the gradient of line 1 is 5 over 2. How about line 2? For line 2, I can rearrange this so it says 2y equals 5x plus 7. And I can tell straight away if I'm going to get it into y equals mx plus b, I have to divide everything by 2. There it is. It's the same gradient. So I'm going to say, therefore, the gradient of L2 equals 5 over 2 equals the gradient of L1. So actually I'm going to say since the gradient of line 2 equals gradient of line 1, then the lines are parallel. Now it's a proof, so you've got to show a bunch of numbers and calculations with a statement. Okay, it's really important. Have a look at the next one. This one's a bit more interesting to think about. It says find the equation of a straight line parallel to this line and this point. This line and passing through this point. Now we have learnt a few formulas. We've learnt the point gradient formula. We've also learned the 2-point formula. So either I can get the x and y intercept out of this, which gives me, or find a coordinate out of this, or just find a gradient and I've got a point. I think I'm going to go the gradient point way. So with my line here, I'm going to rearrange this so it's y equals mx plus b. Just took the y over there. So m is 2, gradient and a point, and Bob's your uncle. So y minus y1 equals m x minus x1. Don't forget, label your point x1, y1. So y take away minus 5 becomes y plus 5. Oh, sorry, no divided by there because we're not using the 2-point formula. Equals m, which was 2, x minus 1. Now I kind of need to expand this. Oh, I lost my 1. So 2x minus 2. Push the 5 to the other side, so 2x minus 7. And that is the equation of the straight line. You probably want to get a bit more practice, so have a go at some of the questions from the exercise. If you can't do them all, that's okay. Have a go. You must write a summary of what you learned. Any questions you have, as well as a hot question, bring it with you to class. See you soon.